Section 2.5 is about function transformation. And what you're going to do in this section is take the base functions and shift them around on your graph. It's really not as bad as it sounds. These are the only base functions you really need to worry about. And you're supposed to know the basic shape and the domain and range of these base functions, but you can get the basic shape of these functions using the graphing feature on your TI calculator. And if you don't know how to graph using the TI calculator, please go out on YouTube and type in graphing using your TI calculator. It will tell you everything you need to know about how to graph functions using your TI calculator. And once you have the graph, you should be able to get the domain and range. The transformations that we're going to perform on these functions are shifting it left and right, vertically stretching or shrinking it, reflecting it around the x and y axis, and shifting it up or down. Now, I'm saying vertical stretch or shrink. There's also a horizontal stretch or shrink, but we are not going to cover that in this course. The transformations need to be done in this order, and I'm strongly suggesting that you just take a minute and write these down and just put them off to the side, and as you work through the problems, just go down step by step. And by the time you're through with the problem set, you should have this list fairly well memorized. So let's start with one that has everything in it. And we're going to find the base function and list all the transformations in order. Now, you're not going to find anything this bad on your homework or an exam. This is just an example so that you see everything at once. The first thing to do is find the base function. So just find the function on the previous page that looks closest to this. And hopefully it won't be too hard to figure out that the base function here is y equals x squared. And now we just have to figure out what to do with it. Okay, the first thing on the transformation list was the horizontal shift, or the shift left or right. Horizontal shifts are shifts inside the function itself. In other words, this one is going to be our horizontal shift. And horizontal shifts work in the opposite direction from their sign. So in other words, we have a +1, so it's going to shift 1 to the left. So there's my horizontal shift. Okay, next was my vertical stretch. And vertical stretches come about by constants outside the function. So this 2 indicates a vertical stretch. And if the number is greater than 1, it's a stretch. And if the number is less than 1, it's a shrink. So in this case, we have a stretch. By a factor of 2. And what that means is we're taking each y coordinate and multiplying it by 2. Alright, so we've done with our vertical stretch. Next we have reflections, the x-axis and the y-axis. Doesn't matter which order you do these in. Reflections come about because of these negatives. If the negative's in front of the function, it reflects around the x-axis. If it's in front of the variable, it reflects around the y-axis. So this negative is an x-axis reflection. So let's write that down. This negative is the y-axis reflection. And the last thing we have to do is our vertical shift. That number outside of the function is our vertical shift, and it goes in the same direction you would expect. So we have a -6, so that drops it 6 down. So now we've taken this function, found the base function, and listed all the transformations in order. Now when you're graphing these for homework on MyLabs Plus, what you're going to do is just click on the base function, and it's going to give you the base function, and then just go through the transformations in order and it will shift it for you. So it shouldn't be too difficult. If you for any reason wanted to graph these on paper, just go back to this original function and plug that into your TI calculator. It will give you the graph, and you can get points for that graph off the table function. Let's try another one. And same basic idea. This is a little bit more complex than you're going to run into in the homework. It just shows all the transformations that you're going to run into. And again, hopefully the base function isn't too hard to find here. It's just radical x. And now let's list all the transformations in order. So we start with our horizontal. And horizontal shifts occur when you have a constant inside the function. We have a -1 here. And again, horizontal shifts work in the opposite direction you'd expect, so that -1 shifts the function 1 unit to the right. Now we do our stretches and compressions. I have a 3 here, so it's a vertical stretch. By a factor of 3. Now I do reflections. I have an x-axis reflection and a y-axis reflection. And then finally I have a vertical shift here 2 units up. And we're done. Okay, now let's do some of the difficulty level you're going to run into. Okay, and this will be a typical problem on your homework or on an exam. And again, first thing we do is find the base function, and hopefully you won't have too much trouble. Base function on this is just x cubed. So let's see what's going on here. Let's start with our horizontal shift. And we do have a constant inside the function. It's a +3. And that shifts 3 left. Okay, next is the stretch, or the shrink. Now, there's no coefficient out in front of the function, so there is no stretch. Okay, reflections. There's no negative out here, and there's no negative here, so we don't have any reflections. And finally, we have a +2 out here. That's our vertical shift. Of 2 up. Let's try one more. First thing we want to do is find the base function, and hopefully there won't be any problem recognizing the base function as x squared. And now we'll just go through our list of transformations. First one is the horizontal shift, and there's no constant associated with the x inside the square, so no horizontal shift. There is a compression or a shrink. The words are kind of interchangeable. So we have that 1/5 there. So that's a vertical shrink by 1/5. So what that 1/5 does, what the vertical shrink means, is just take all the y coordinates and multiply them by 1/5. See, there's no negatives out here or here, so there are no reflections. But we do have a vertical shift, 4 up. And we're done with this one. Now let's go in the opposite direction. So on this one, I'm given the base function y equals absolute value of x, and I want to shift it 6 left and 3 up. So remember, shifting it 6 left means that the constant 6 has to go inside my function. And I'm going to have the opposite sign to the direction. So if it's going this way, it's going to be a positive. So the +6 will shift it 6 left, and 3 up is just adding 3 outside the function. And we're done. Let's do one more. Okay, the base function here is radical x, and I want to shift it 2 left, 8 up, and reflect it around the x-axis. Okay, so shifting it to, let's do the 2 left first. The 2 left is going to be a constant inside the radical, and left is a positive. 8 up is a +a outside, and the reflection around the x-axis is a negative outside of my function. And I'm done.